Okay, welcome everyone to this webinar about synthetic data and especially how you can anonymize your dataset using synthetic data. But first of all, what is synthetic data? Synthetic data is data that is generated artificially with engineered properties. And Gartner predicts that in a few years it will be at its peak hype and there will be a mature technology in 5–10 years. There are already industries where it is an established technology. For example, the automotive sector, where synthetic data is used to simulate situation and help train automatic cars. But what are the challenges that synthetic data can solve? And there you can see already anonymization comes in. Because data is everywhere, but often it is not usable or available. If it is not usable, it could be due to confidentiality or secrecy reasons that prevent to share data, and in general slow the mindsets of companies that do not think they can innovate using data because they cannot use data. So today, this is the use case that we'll see the most with anonymization. But the other reason to use synthetic data would be actual lack of data, because you're developing, for example, new applications where data is not available yet. So let's recap also briefly the two types of synthetic data. There is rule-based, where you can start out of nothing and just using rules build datasets. But what is more interesting for us today for anonymization is statistically generated data, where essentially you have an input dataset. In our case today for anonymization, it will be the dataset to anonymize. And then using rules, you can infer the properties of the dataset and generate new data. So, but let's see what are the levels of anonymization and the path to, let's say, synthesization of dataset. So there are several levels of anonymizations that strike a balance between the privacy of the dataset and loss of information. So also what you can do with it, because if you lose too much information, you can do less. So the first level would be tokenization. This means replacing labels with pseudonyms. For example, you can replace John with Jean and Luke with Mark, or IDs as well. So this is anonymizing the names, but it's not a very strong method. Using the other fields of the datasets, you might de-anonymize quite easily. So this is mostly used for preventing data loss due to errors in cases where you have already a trusted source. So you're pretty sure that the data will not escape anyway. Another level would be generalization. Generalization means essentially building groups to have individuals fit into a crowd. So for example, if you have Italians, French, and Germans, you can build a category Europe that will include them all. In this way, the single nationalities will not be detectable anymore, and it's more difficult to de-anonymize. So this is already more secure method, but it can still be undone. So using synthetic data, fully synthetic data is the most secure method, where essentially you do statistically generated synthetic data, detecting the properties of the dataset, and then reproducing that new data with the same properties. An example could be drawing a random city from a list of cities with the same probability of the input dataset. Of course, in here you lose a bit of information, so it is not usable anymore to analyze individual records. On the other hand, you can still use it for statistical research or for testing, where you want to test, but you don't want your data to handle, to have real names in it while you're testing. So what is MakeYourData? MakeYourData is a tool that we developed at Argusa to generate synthetic data in a few clicks. So this is a comprehensive solution, and it includes several methods to anonymize datasets as well, and also several connectors to fetch your data where it is, and it can be used with minimal training. So that's two typical use cases. If you have to anonymize your dataset, like we'll see in this demo, typically you have an input dataset. You can imagine to hide the names, then you use the tool to do that, and then you can share your data with your external support. The other use case for the tool would be something that we'll see more in the next demo, which is generating data out of nowhere, just to train a new application for which data is not available yet. So let's see what features MakeYourData provides for anonymization. First of all, it is flexible. You have a range of methods that you can use to anonymize all kinds of data, so text, but also numbers, dates, and so on. Even complex methods like anonymization and various types of noise. Also, you can keep readability of your dataset, because if you anonymize converting everything to IDs, then the dataset is essentially unreadable by a human. On the other hand, you can, for example, use names to hide names and departments to hide departments, in a way that you keep the semantics of the dataset altogether. Furthermore, you can choose your anonymization level. The tool proposes to you, as you will see, different methods and different levels, and you can choose your level and then customize the methods afterwards if you want to go deeper in the details. It also provides a way to transparently retrieve the original records. This could be useful, for example, in cases where the typical example is an hospital where which received your anonymized dataset to analyze the data and find illnesses in patients. If the illness is found, you want to go back and contact the patient. So you want a secure way to go back to the original information, and MakeYourData provides that. And finally, you have self-documentation, so a PDF that is generated with all the rules that are applied, and then can be used for compliance reasons and documentation. So before going to the demo, I remind you that this is a webinar in a series of 4 webinars. The first one was a couple of weeks ago about using synthetic data to prototype applications. Today is about anonymization, and the next 2 will be in autumn. The dates are not yet set, but will be about building demos and training machine learning models with synthetic data. For the first webinar, you have the QR code to see the registration, and for the next one, you already have the page where you can register, and we'll keep you posted on the date where that will happen in autumn. So I will now the floor to Thomas, that will show you the demo about anonymizing data with MakeYourData.
Hello, everyone. So today will be an online retail company who has a table with orders online. As you can see here, we have the ID for the order, the date of the order, the ship date, the customer name, birth date, postal code, city, state, and information on the product and on the sales made and the profit. Your goal as a company is to give this data to an external company we will be able to carry some analysis and look for trends on your data to see if maybe you're making more profits on some type of products or in certain periods, seasons of the year, if you're making more profit in given states. But of course, you don't want to share confidential information with this external company. There's several parts in this data that are very confidential. First of all, and the clearest one is a customer name. We don't want to give our customer names to external companies, and also often we are not even allowed to do it. We have a lot of social demographical information on the customer, such as his birth date and his city and state. Combining both can make you find who the person is without even knowing his name. So we'll need to have some kind of anonymization here to ensure that we are not able to retrieve a single person just by his birth date and his postal code, for example. Then we also have profit and sales. These are not columns that are particularly dangerous for like retrieving someone, but are much more dangerous for the company because we will be able, by aggregating these values, to retrieve how much profit the company makes every month, or how much sales do we make every month. And we don't want to give this kind of classified information to an external company. So to anonymize, we'll go on to MakeYourData program. So this is the homepage of MakeYourData, and we'll start a new project. We have several options to load files, either from CSV, Excel, or Tableau files, or from SQL databases. We have 6 of them, and also from Scratch tables. Today, I load the Excel file I've just shown you. I retrieve it in my computer, and it is this file. Once the file is loaded, you can have a table preview here in the visualization part. So you can have a first look at the table I just have shown before. With anonymization, MKYD has an accelerator, so we can use some accelerator to give some rules of anonymization without having to set all the rules manually. I'll just show you now how to do it. I push on the button, use anonymize accelerator. And here we have anonymization level. We have 4 levels of anonymization. Either we have no anonymization, we just keep the input column as it is. We have soft anonymization, which anonymize a little bit the column, but not too much. Strong anonymization, that anonymize strongly the column, and we can delete the column. Here, because we have a lot of columns that we want to anonymize, I just select a global strong anonymization level. So by default, all the columns are set to a strong anonymization. I'll go over each column to show you what happens. So the order ID, here we see that the order ID is very specific to our company. We have the year in which the order has been made, the country, and some information afterwards. If someone knows how it works, he can smartly revert this order ID and have some information on the customer or on the local or on the year of the order, and we don't want it. So what we'll do is to anonymize this order ID by using a progressive ID. This progressive ID will just give an ID from 1 to the number of rows to each row. I'll show you afterwards. The order date and ship date are not crucially crucial columns to anonymize. However, we still want to add some noise, so we don't want to have the exact date in order date and ship date. Why? Because else people will be able to retrieve information on patterns in the dates and to be able to know which command, which customer corresponds to which rows, only by knowing that a given customer has done like 10, has both 10 items the same date, and he's the only one to have done it, he will be able to retrieve this information. So I'll add some nodes to order date and ship date. Afterwards, we have the customer name. As I told before, it's a crucial sensitive information, and we want to anonymize it. So we'll leave it in strong anonymization so that it uses default MKYD names. Then birth date is not super sensitive, but as I've told before, combining birth date with geographical information becomes sensitive. So we'll just add soft anonymization, which will truncate the birth date to the month. So we won't have the real date of birth, but only the month and the year of birth. For the geographical information here, postal code, city, and state, one way of anonymizing is generalizing, and this is what will be done here. Most often, we don't need to have specific geolocalization of the customer to be able to have geographical trends. We only states is well enough to have some trends to see if California sells more of a given product or like North Carolina of another. So I'll just delete postal code and city. And I don't want to anonymize state as this is a crucial information. So I'll just leave it to no anonymization. I have already pretty much anonymized the geographical location of the customers. Then we have information on the product. This is not confidential information at all. Moreover, it is very useful to keep them as they are because this is essential for our analysis. We want to have the proper product names, the proper categories for each product. So we'll just select no anonymization. Quantity does not require anonymization, so I'll just take no anonymization too. Then we have profit and sales. These are both crucial columns to anonymize, so I leave the anonymization level to strong anonymization. Once I have done all these, I can go to load data and we'll just end at the classical interface you have already seen in the previous demonstration. So on the left, we have an overview of the columns we have in our table. At the right side, we have on top the overview of the first 8 rows from input and output, given the anonymization we have done in this part. And we see here that for the order ID, we have used an anonymization option with a from column distribution and ID. What it does is that each row, each unique value of the order ID in input corresponds to a number in output, from 1 to the number of unique values, here 137. So we see that here we have twice the same order ID. It will give the same order ID in output. For the order date, we have added some noise so that we don't have the same exact date in input as in output. First of all, we see that in input we have only dates and no time. So I'll change the data domain from date and time to date. And we see that there's a lot of difference between the dates here and the dates here with more than 7 months difference. So what I'll do is I'll change the type of noise to Gaussian noise. And I'll configure the distribution so that the noise is smaller and we have a standard deviation of 2 days. So that we will add some random days to each date that will span between +4 days and -4 days symmetrically. We see that now we have much more similar dates, and this is better, so we keep seasonal trends in our data. For ship date, I'll just do the same, so I'll change from date and time to date. from differential privacy to Gaussian noise, and the standard deviation to 2 days. Moreover, I have to add a constraint because ship dates are always after order dates. So here I add the constraint that ship date generated is greater than order date generated. Save modifications. And for the customer name, so here what we have selected by default with strong anonymization is to replace the customer names by MKYD generated names. And we see that because we are in anonymized form column, each input name corresponds to the same unique value of the input name corresponds to the same value in output name. So Claire Good is always William Williams. Just so that we mark even more the difference, I'll change the names from our MKYD labels from English to French. And I'll just reduce the number of unique labels to 130. And when we save, we see that now we have really made some big changes with French typical names as customer names. So the birth date, we see that we have truncated to months. So now we don't have anymore the day of birth. We only have the month and the year of birth. This is perfect for us. We'll just leave it as it is. State doesn't need to be changed because we have already anonymized by removing city and postal code. So we'll just leave it as it is. Category also, as explained before, we don't do anything more with it. Product name, the same as category, quantity also. And now we go to profits. So the level of the strong anonymization option gives a noise to the data and rescales it. However, now it has rescaled it between 0 and 1, and this is not visually very impacting. Moreover, we have profits that are negative and positive. So going from 0 to 1 won't show that we have negative profits, positive profits, and it's not very visual. So what we'll do is we'll rescale between minus 500 and 200 in order to have better, less shift and more rescaling in the data. And I'll just increase the error. I'll just reduce the error by this epsilon factor, which is the opposite, the inverse of the error range. And if I save and go back, I see that I have much less shift, and I have only 1% of the range that is given as error. So we have small errors. We see here the changes that have been made. And lastly, I'll change the sales. So for sales, here we have added rescaled and added noise. For the sales, we'll use another option, which is called K-anonymity, and we will group sales values into categories. With that option, we remove the specific value, we hide the specific value of the sales to the external consultant that will see data. However, we will still have grasp the range of values in which the sale lies. So for this option, I'll change the distribution to K-anonymity. When I go to the options, here we have a K-anonymity factor. It gives how many sales are grouped together per minimum. So we have at least 10 values of sales in each group, which is quite enough. And I'll change the data domain to a range. And when I save, we see that now the data that was before a number is now a range of numbers in which we have grouped, for example, all the values between 7.28 and 261.96 together, and then all the values here between these two values together. We have even specific values we have anonymized these, but keeping values within categories of sales. Once this is done, I finished anonymizing my dataset, and I can go to data generation. Here on top, we have a small recap of changes made and how we anonymize all the data. You see that birth date, state, category, product name, quantity are not changed, so that data is on original data. Others are all anonymized. Also, as Luca has told you, we can retrieve input rows from output rows by a secure key. This is the hash column. I just tick it. And when I generate a hash column, I will generate a table, a column that with an unique identifier based on the data in the input table to be able to make correspond input and output tables together. Because we generate this key in output, we also want to generate it in the input table so that you keep the input table inside the company. You give the output table with the hash key to the external company. And when they tell, okay, this row with a hash key, whatever, you are able to retrieve to which row it corresponds in the input data. So I just tick this. Now I go to the saving part. So I'll choose to save the data as an Excel file, and I'll just call it Superstore anonymized. I won't add or remove rows because it doesn't make sense when I anonymize data. We have also the option to save the project if you want just to save the configuration and keep it for later, but now I'll generate data. It takes just a bit of time because of the key anonymity, which is a state-of-the-art algorithm of machine learning to group columns together. So once data is generated, here is the output result. So we see that we have the order ID generated with each order ID in input. It corresponds to the same order ID in output. And we have just numbers, so we have anonymized the order ID. We have order date and ship date. We see that even if we have added some errors to the date, some noise to the date, we see that constraints are still valid and that order date is always before ship date. And in a global view, we will have the same statistical properties in the order date in input as in the order date in output, even if we have added some noise. We see that we have the customer names. So now we have clear French names that we have changed. The external company won't be able to retrieve specific customers from this table, which is essential. We see that we have anonymized birth date and geographical location. So it's much harder to retrieve someone born March 36 in Kentucky than retrieving someone with the proper date, with the proper city and the proper state. We haven't changed category and product name, which is essential for our analysis and visualizations. We haven't changed quantity. We see that we have rescaled profit so that the external company can't have an overview of how much profit is made, because if we added only noise, by aggregation, we keep the same statistical properties and the same aggregate values or an approximate value. So we have rescaled. We keep negative values, positive values as the proper profit was. So for visualization, it's very good. We keep correlations with other columns, and we have anonymized it. And for sales column, we have grouped sales together. So if we look, we know that in each range of sales, there's at least 10 sales in it. So we have anonymized each sales, but always considering that we keep a global value for the sale. So we know that this sale lies between 218 and 275. And we have an overview of each sales value. So that was it for the project. I hope you enjoyed and that you found the demo insightful.
Okay. Can you stop sharing? Thank you. So thank you for listening. And I just remind you that you can download your free trial at www.guza.ch MKYD. And if you want to watch again our previous webinar, it is available with this QR code. Of course, this webinar will also be registered and we'll put it available. And for the next webinar, you have it on the previous slide, the QR code to register already. And the date will come out in autumn. Thank you and have a good day.